We've never said all mountains are melted buildings. We've never said that.
We have sort of a problem here. Yeah. Did you see the memo about this? Yeah. If you could just go ahead and make sure you do that from now on, that would be great. And, I'll go ahead and make sure you get another copy of that memo.
All mountains or buildings. They're melted buildings. All mountains are melted buildings.
Most, if not all, mountains are melted buildings.
Mountains are nothing more than melted buildings.
Mountains are melted red brick buildings, people.
100%. 150%.
No, there's no such thing as mountains. They're all melted buildings.
Mountains are melted buildings, as we keep saying.
Repeat after me, Doctor. Mountains are melted buildings.
Alrighty then.
If all mountains are melted buildings made of red bricks, how many bricks would it take to build them, assuming the total volume of Earth's mountains has been estimated at 10 million cubic kilometers?
Producing approximately 9.75 quadrillion bricks is an incomprehensibly vast logistical challenge that would require scaling industrial processes to unprecedented levels. Here's a breakdown of the logistical considerations. 1. Material requirements. Each brick typically requires raw materials like clay, shale, sand, and water. For this scale, clay-shale requirement. A standard brick weighs about 2.5 to 3 kilograms, 5.5 to 6.6 pounds. Assuming an average weight of 3 kilograms per brick, this would require 3 text kilograms per brick times 9.75 times 10^5 thad bricks equals 2.925 times 10 grams of raw material. That is 29.25 quadrillion kilograms of clay's shale. This would need extensive mining operations, potentially depleting global clay reserves many times over. 2. Energy requirements. Brick production involves firing bricks in kilns, which requires significant energy. Firing a single brick typically consumes 1 megajoule of energy. Total energy required 1 text mj brick times 9.75 times 10^5 bricks equals 9.75 times 10^15 mj. This equals 9.75 billion terajoules, or 2.7 quadrillion kilowatt-hours, kWh. Whoosh! This is roughly 20,000 times the annual global energy consumption, estimated at 150,000 watt-hours in 2023. 3. Manufacturing infrastructure. To produce this many bricks, a modern brick kiln can produce 100,000 bricks per day. Bricks needed. Text daily output per kiln equals 9.75 times 10^15 scare 100,000 approx 9.75 text kiln days. If 1 million kilns operated simultaneously, production would take 267,000 years. To achieve this in a human lifetime, 50 years, 200 billion kilns would need to operate simultaneously worldwide. 4. Transportation challenges. Transporting the bricks to build Earth's mountains, a single truck can carry 5,000 bricks per load. Total trips required: 9.75 times 10^15, text 5,000, bricks per truck equals 1.95 times 10^12 truckloads. Assuming a 50 kilometers average trip per truckload, 1.95 times 12, text trips times 50, text kilometers per trip equals 9.75 times 10^13 kilometer. This is equivalent to 650 million round trips between Earth and the Sun. Workforce and automation. Workforce. Even if fully automated, billions of workers would be required to operate, maintain, and supervise this infrastructure. Automation. Robotics and AI would need to handle processes like excavation, molding, firing, transportation, and placement. 6. Environmental impact. Carbon emissions. Producing and firing bricks emits significant CO2. At 200 kilograms CO2 per ton of bricks, 9.75 times 10^5 bricks times 3 kilogram brick times 200 text CO2 per ton equals 5.85 times 10 CO2. That's 585 trillion metric tons of CO2, which would catastrophically impact the planet. Mining impact. Mining this much clay shale would devastate ecosystems and landscapes. Time frame. Even with current global resources, this is a multi-million-year project. Scaling production to achieve this in 50 years would require industrial output many orders of magnitude higher than the current global economy can support. Conclusion. Producing 9.755 quadrillion bricks is beyond the capacity of humanity's current technological, environmental, and economic systems. It would require breakthroughs in energy production, like near-limitless fusion power, materials science, automation, and a re-evaluation of resource extraction and planetary-scale logistics.
To produce approximately 9.75 quadrillion bricks to build all Earth's mountains, what would be the logistics of producing so many bricks?
Producing approximately 9.75 quadrillion bricks to build all Earth's mountains would be a colossal logistical challenge. Let's break this down into major considerations. Material requirements. Raw materials for bricks. Standard red bricks are typically made of clay, sand, and water. To calculate the raw material requirements, weight of a brick. A typical brick weighs about 2.7 kilograms. Total weight of bricks. That's total weight equals 9.775 text bricks times 2.7 approx 263. That's times 26.3 quadrillion kilograms of raw materials. Challenges. Clay availability. Extracting such massive amounts of clay would likely deplete Earth's reserves. Sand shortage. Sand is already in high demand for construction, leading to a global shortage. Environmental damage. Mining this volume of materials would devastate ecosystems, destroy landscapes, and disrupt the planet's balance. 2. Brick manufacturing. Production capacity. Current global brick production, roughly 1.5 trillion bricks are produced annually. Time to produce all bricks. Text frac 9.75 times 1015, 1.5 times 10 year, approx 6,500 years. Even if the world's production were scaled up 100 times, it would still take 65 years to produce these bricks. Energy requirements. Bricks are typically fired in kilns at 1,000 degrees Celsius, requiring significant energy. Average energy to fire one brick, 1.5 megajoules. Total energy requirement. Text. Total energy equals 9.75 times 10 to 15 times 1.5, text mj, approx 1.46 times 10's mj. This is equivalent to 4.05 quadrillion kilowatt hours, or approximately 30 years of the world's current energy consumption. 3. Transportation and distribution. Global infrastructure. Shipping bricks. Assuming an average truckload carries 10,000 bricks, you would need frac 9.75 times 10 to 15, 10,000, approx 9.75, 10 truckloads. That's 975 billion truckloads. Carbon emissions. Transporting these bricks would emit untold amounts of CO2, contributing to climate change. 4. Workforce and factories. Labor force. Brick production is labor-intensive in some regions and automated in others. A project of this scale would require billions of workers or automated facilities. Assuming each worker can produce 1,000 bricks a day, you'd need 26.7 billion workers producing for a year. Factory expansion. Building enough brick factories to meet the demand would require enormous land areas, additional energy and raw materials for factory construction, global collaboration on a massive scale. 5. Environmental and ethical concerns. Deforestation. Clay mining often clears forests, and kilns may use wood or fossil fuels, worsening deforestation and pollution. Ecosystem disruption. Entire regions would be destroyed to mine materials and produce energy. Ethics. The displacement of communities and the exploitation of labor would be major concerns. Feasibility. In short, producing enough bricks to replace Earth's mountains is logistically impossible with current resources, technology, and infrastructure. However, imagining such a project highlights the vast scale of Earth's natural systems compared to human industrial capacity.
Say woof again! Say woof again!
I've got one that can see.
This is my kung fu, and it is strong.
See you later.